go. And we're going to switch over to this new setup I've got. All right. So this will be a recap, but I think since it's a new concept, it doesn't hurt to just go over things again, and hopefully it'll go a little smoother. I've got a new way to do my slide indentations today, so we're gonna try this out. All right, so objects, right? Come on, there we go. So, oh my gosh, one moment. Let me make sure my slides look correct on here. Surface. Sorry, it's too much technology. Okay, can you see the whole slide now? Great. All right, so we want to create a battleship game, of course, and this is a slide we talked about yesterday. We want to figure out what sort of data do we need to store to be able to recreate these ships, maybe on someone else's screen or from a saved file, for example. And also, what are some functions that we need to write in order to manipulate these ships and actually play Battleship, right? So we already went through this, but just to recap, right? We'd like to know the bow location of the ship, as well as whether it's horizontal or vertical. So if it's horizontal or vertical, and also the length. And with these three pieces of information, where the bow is, how long the ship is, and whether it's vertical or horizontal, we should be able to, that fully defines the ship placement on the board. Do you agree on that? All right, so we need these three state variables. And then once the game begins, we also need to track how many hits each ship has and where those hits are. So that turns out to be a fair number of variables. And we need to keep those variables separate for each ship. Right? For every ship, we need its length. For every ship, we need its bow. For every ship, we need its orientation. We also want some functions. We want to be able to do things with our ships, like hit them. We want to be able to tell a ship, hey, the guess was, C7. Is that a hit or is that a miss? Did that hit you? And the aircraft carrier should say, nope, didn't hit me. And the submarine should say, nope, didn't hit me either. All right, so we'd like some function like is hit. So if we were going to do this, let's keep that there. If we were going to write this using the tools that we know so far, we'd have to have a fair number of variables, and the names for those variables could get complex, right? So here we've got the set of variables, and so for each one of the ships, the submarine and the carrier, we have a full set of variables, a full set of those four state variables we discussed in the first slide. And if we want to do something with this ship, any function has to get all of those state variables as inputs, right? As well as the actual guess, So it would be nice to lump these variables into some single entity and be able to pass that around instead, rather than having these separate variables that we all have to do the bookkeeping directly on. And so an object is a code structure that consolidates all these variables into one thing, and also associates functions with those variables, so that we don't have to go through this painful process of calling functions with like 15 parameters. All right, so we talked about all this last time, and one, we'll call them code smells. If you look at some code, it's not that it's wrong, like code can certainly run, but sometimes some code is better than other code, and so if their code has particular kinds of warning signs in it, the common term is that it smells. And so if you see a function changing one of its own parameters, like here, if is hit, then hits that append, and hits came from this parameter here, it's actually changing its own inputs. that's an indication that maybe you should consider using an object rather than flat functions. And so we'll talk about that. But that's the annotation on that slide there. Okay. All right. So again, this was all from before. So I'm gonna get better. I try to keep my picture on here, but I realize these slides, my picture kind of blocks things. So there you go. All right. So what we would like to do, can you read the text on these slides? Yeah, okay, good. So can we combine function and state? The answer is yes, that's what objects are. So here are some examples of objects. We have a car and a printer. These are generally like nouns, like people, places, or things, right? And our objects have two parts. Their state, which defines kind of who and what they are. For example, a car is defined by its fuel level and its mileage. And it might be defined by more than that. We would just have more variables here, but I don't want to clutter the slide. Your state should be enough to fully recreate a car from scratch. Like if someone told you, hey, here's all the attributes, you should be able to create the identical car that they have. Okay? It's almost like some sci-fi movie where like if you clone my brain and put it in another body, blam, you have another John Donald. Okay? The state fully captures the essence of the object. Then these functions are the capabilities of that object. So a car can be refueled, right? And you can drive a car. When you do drive a car, you might have to give it some information like a destination, where do you want that car to go? And in the process of driving, the car might change some of these state variables. Its mileage will increase and its fuel level will decrease. Okay? You understand how these functions allow a user, somebody that created the object, to go ahead and do something with them. And by doing something with them, you're going to be adjusting the state variables. A printer, different than a car, but the same idea, right? Has some ink level, some pages printed, and maybe you could print something. And as you print something, then of course pages printed goes up, ink level goes down, the same idea. All right, now these are just models of reality. There are, I suppose, infinite variables in a printer. Part of your job as a programmer is to figure out what parts of the printer are important to capture in your object. You don't necessarily need to capture the color of the printer itself or the GPS coordinates of the printer, even those are all things that could be captured, right? So part of the programming exercise, right, is defining your objects and what state variables you need to make them operational. Okay, so when you use an object, so here's the idea, right? Now I've defined these objects at the top here, and I've created two objects. I've created a car, and I've called it my Toyota. Okay, and I've created a Cadillac, and these are both the same type of object, but they're different. Notice that their internal state variables are stored separately and have different values, and so I've indicated that by color. So the Toyota's fuel level is different than the Cadillac's fuel level. So to use these objects, the syntax is going to be the name of the object dot the method, right there, or the function, I guess, right? So you can drive a Toyota just the same as you drive a Cadillac or refuel them, right? But notice how we're flipping it. It used to be that we'd put the function first and then all the parameters. Now we're putting the object first, dot its function, and then any parameters that function wants. So here, New York is the destination, right? Does that make sense? Do not access the state variables directly. I've put a little padlock next to them to suggest this, right? Python will let you touch the state variables, and sometimes we will, but it's poor practice. You should put fuel in your car by using the refuel function, not by just arbitrarily setting the fuel level to 100. Okay? Now, I guess let's pause for a minute. Why do you think we strongly recommend not touching the state variables directly. Why do I not teach you by cracking your head open and putting electrodes in your brain? What could be the outcome there?
Or does it have anything to do with that? Like, if you make one change, you have to make changes to every single time you use that because you're like hard coding it, or is it?
No, that would be setting the fuel level. I mean, that is possible. You could just arbitrarily say, I have 100 gallons of fuel in my Cadillac, right? But just the same as I could say, you're defined by, I mean, let's just make this up, right? I don't necessarily believe this isn't at all true, but you're totally defined by your synapses and neurons and stuff, and I want to go and change Kyle's neuron to shoot to the left a little bit, and that's going to teach him Python. I've decided this, right? I think the danger there is that I kill him, right? That somehow I don't know what I'm doing with the state variables, and I shouldn't interact with him at the neuron level. I should interact with him like through his ears by like teaching him. Maybe he has a method called learn, and if I talk to him, he'll figure out how to do it with his neurons. Okay? I mean, this is a crude analogy. Maybe it makes you smile. But the same way with the fueling. The Cadillac probably has restrictions on its fuel level. Like, it can't hold 100 gallons of fuel. It knows this, right? When you refuel it and you try to put 100 gallons, maybe that function can go, oh, sorry, I'm full. Right? If you arbitrarily go into this object and go, I'm changing your state, you might set it in some weird way that it no longer works quite right. Maybe the programmer that created this object has some assumptions. Like it's tracking, when you call refuel, it's also setting some other parameters in addition to fuel level, right? And so it's considered poor practice to bypass the functions. Those are kind of like the interfaces you have to the object. Don't go past the interfaces and start tweaking everything directly. I think you'll see this more once we get started writing our own objects here. But we always want to use the functions, the capabilities that the objects expose, rather than change their state directly. How are we doing so far? Brooklyn, you're good? Greg? Okay. Just calling out random names here. Not to pick on anybody. Can we go further? All right. Okay, so we need to set up some terms here. The idea of a class, an object, and self. So in the previous slide, we just talked at a conceptual level. Let's go back to that idea. And at the top of that slide, notice that I had the definitions of cars and printers. And at the bottom of this slide, in the colors, actually had instances of cars below. Okay? So the class is actually the code you're going to write. You're never going to write an object. You're going to write a class. A class is like the recipe, the instructions. How do you create a car? And what does a car do once it's created? An object is an instantiation of the class. Okay? Oftentimes in textbooks they'll talk about classes being a cookie cutter and an object being the cookie. Right? You can use the class definition to stamp out a bunch of objects. I can use this car definition to create a Toyota and a Subaru and an Outback and a Jalopy and whatever else. Do you understand this distinction? So we'll talk about objects, but you'll never actually use the word object anywhere in Python. You'll use the word class to define the car thing, and then you'll create objects using that class. And the type of the object is its class, right? The Toyota's type is car. Okay? A little trickier, right, is this idea of self. Self is this blue table. When you create the object from the class, you get an empty table. Right? And then what you can do is actually start to define, you can define things to store in that table, and that's the state. So self is this table here. It is the mind of the object, the memory of the object. If you have access to self, you can tweak all the neurons and everything. The only person, I say person, my anthropomorphisms go out of control sometimes. The only place where you should touch self is within the refuel function in this case. Only refuel should have access to self. Only Greg's body should have access to his brain. I have access to his ears, and you know, we can reach out and touch each other in better times, right? But only Greg can figure out what happens in Greg's brain. Only he has access to the self. Well, I hope these analogies end up making sense in the end. I'm a little embarrassed of myself at this point, right? But so let's try to write some Python here to create this car. Okay? So look at this code for a moment while I make myself a little bigger, because I can. Now you see me. This way you can see my beautiful hand gestures, which I work so hard on. Okay? Now notice in Python, once we're writing code here, this is the new syntax. We created a class here. And we created a method. Well, these are often called methods when you're talking about classes, but they're just functions, right? Here is the refuel function. And we know from the previous slide that the input to refuel is the number of gallons you want to put in the tank. So down below here, you see first use the class to create an object. Right, so we're using the car class to create a MyToyota object. And once we have MyToyota, we can say dot and call its methods, right? Call its functions. Refuel 10. Okay, now what does refuel mean? Well, that's defined in the class. That's in the recipes up here. Notice that there is an extra parameter to refuel called self, and that's how objects work. When you define a function inside of this class, it gets this extra freebie parameter called self, which you can then use to access that table, that blue table from the previous slide. So we can set self.fuel. But there's a problem here, right? So what's the problem if we were to run this code right now? In fact, do this, right? Actually type this in your scratch.py file right now. And try to run this code. And I'll do the same as well. That way we're all working. All right. So can someone tell me the error message you see when this thing tries to run?
It says that there's no attribute fuel.
Yeah. Why does it? Yeah. So line 3 here, we're setting fuel equal to, and this is the first time we've referenced fuel. So this is not like we're kind of creating that entry in the table as we go. and we're setting that new value equal to itself. But, you know, we get this kind of circular reference here. We're trying to use a variable before it's been initialized. All right, and this is probably a problem you've seen in other places, like in 200 and other, right? We need to somehow initialize fuel. We need to give it probably 0, right? So when you first get a Toyota, it doesn't have any gas in it. Do you understand the problem? Okay, so this is, you know, not unique to a car. Pretty much every object needs some set of initial state variables. Okay, so we're going to do all that together in a special method, a special function called a constructor. And I think this is where we sort of left off at the end of last class, so hopefully now we'll all come full circle. So a constructor is a function that's called when you create the class. When you create the object. And you can see the syntax here by the fact that we put these parentheses after the name of the class. Oh, no. All right. So the default constructor, it means do nothing. Leave that blue table empty. Okay. So let's add a constructor. Now the trick is to, you know, the way we do that is by defining a new function in our class called __init __. And every programming language that supports objects has a slightly different way of defining a constructor, and none of them are elegant, at least, you know, in my opinion. It is what it is. It's called, you know, it's short for initialize. And the way this constructor works is that you get a single parameter called self, and you can use that to then set up that blue table, that table of state variables. Okay, so in Python, we don't declare our state in the class. Other programming languages like C++ would say, hey, you know what, before you can go any further, when you define a car, like there should be a part of that file where you write the word fuel level as a float and mileage as a float, and those should be at the top of the class. In Python, everything's dynamic, and so this blue table is empty. There's no such thing as fuel level or mileage until you actually reference it and put it into the self. Okay? So here we got self.fuel is 0, and now once you get to the refuel function, that'll work. And of course, note that both of these, the constructor and the refuel method, both you have self as the first parameter, but that's given for free. Actually, what's happening is that refuel is a function that's called by Python, and it looks to its left and says, hey, who called me? My Toyota? Oh, that'll be the first parameter into this new function, right? So it kind of looks to the side, grabs the name of the object, and that is the self that goes into the method, into the function. So let's make sure that this works. Let's go ahead and modify our Python code to add a constructor. Okay. And now when we run, we shouldn't see any output. If you wanted to kind of see how these things work, you can always put print statements, like print building a car with no gas, and then print car has %d gallons of fuel, right? And so now if I fill it up twice, you'll see that I get 15 gallons of fuel if I give another 5 gallons here. So first you built the car, then you give it 10 gallons, and now look, it has some memory, it has some persistence. That self has the value of 10, so when you called it the second time, it now is 15 gallons. What do we think? Yeah? You can be honest here. You can say, this is bogus. Nobody believes you, sir. You're just making up things. Okay.
So when you just how you written it, like the mytoyota.refuel, that line of code basically says run everything in the define refuel.
Yes.
With that inputted, like you put the 5 in, so that means gallons will equal 5 when you run it.
You got it. Yep, exactly.
Okay.
Yep. Right. And in fact, let's see if we can just do this as a clever trick here. We can put breakpoint in, use your debugger, and then when we pause here, you see that gallons is 10. And if I look at my locals, you see self. The only thing in self is fuel. If I play through, continue. The next time I get called, the input is 5 here. It currently is 10. And so the result is that I get 15. Good? All right. See if you can, as an exercise, implement the drive method, the drive function, and rather than it being like some destination and complicated, just put the number of miles there as the input, and then increase the mileage. So you're going to need to add a new state variable called mileage, and you're going to increment it the same way as refuel works, just with different words, right? The mileage is going to take in miles, and then, drive is going to take a miles parameter, and that should increment mileage. So try that out. I'll be right back. How are we doing? Are we successful? So let's see. What I would do is I would come up here and say self.mileage, and it's a new car, so it shouldn't have any miles on it. And then I would say def drive self.mileage, and then the shortcut that I think is pretty convenient is the plus equals. So that's saying self.mileage equals self.mileage plus miles. Or I could say to sort of the mileage, or maybe has driven. Okay. And now you could say my Toyota.drive 100, and we'll get this result. Now, the nice thing about once we have objects, my Toyota is really encapsulating two state variables here. I could have said, written this whole program using my Toyota underscore fuel and my Toyota underscore mileage, and as I added more parameters of this car, I'd have more variables, but you know, Toyota kind of captures all those together. And then if I have more cars, it's simply a matter of creating another car. Your Toyota, everyone has Toyotas, is another car. And your car is only driven 5 miles, but mine's driven 100 miles. Right? So these objects each has their own little spot in memory which keeps all its variables together. They don't conflict with each other. And this allows us to, really model reality in a nice way. Before, you might sit there and have tons of variables and these functions have crazy parameters. Now we actually have these objects. And you could tell someone who doesn't code at all, like, oh, hey, this is the ship object, and it tracks its hits, and it has a length. And they could go, yeah, I don't know how you'd actually write that in code, but it makes sense to me. I believe it. Right? So it's a really nice paradigm to organize our thoughts in code. All right, so a little exercise there. Why don't we switch back? Let's see how far we can get. So that's a fully functional car, I'd say. If all you want to do is add fuel to it. All right, so let's finish this up now and go back to Battleship. All right, where can I hide? Huh? Very nice. So back to Battleship, we have here's where Google Drive messed me up. Let me fix this for 2 seconds because I'm OCD. And I'm just going to move this guy so a little bit. Sorry. This is a bit silly, but okay. All right, so here I've put Python code just copied out of PyCharm with that coloring in font, and then green are my annotations. Okay? So now we have the ship, and we're back to the state variables we discussed. Bow is vertical, length, and so I've changed things around a little bit to say the orientation is actually just a flag whether or not it's vertical. And so since there's only 2 states, it's easy enough to capture it in a true or false rather than the string vertical and the string horizontal. Okay? So look at this constructor. This is a little bit fancier than the car. Notice that the constructor itself takes in 3 parameters. Whereas our car, you could just create a car and give it no other information, and blam, you had a car with no miles and no fuel. To create a ship, we actually, need a bit more information. If you go to the shipyard, in the Battleship game and say, give me a ship, they would say, well, how long should it be? And should I make it horizontal or vertical? And where should its bow be located? And you're like, that's right, I need to give all that information. Do you need to tell the shipbuilder how many hits your brand new aircraft carrier has? Hopefully not. Hopefully the ship, brand new, fresh out of the Battleship boat dockyard, has no hits. So state variables that have a safe default, you can just specify, like fuel or mileage. We just set those at 0. But for state variables that you don't know that there's no default value for, you pass them in as parameters after the self. Okay, and then this is a little verbose. It just is the way with Python. This is the Python syntax. These are local variables. Bow and is vertical and length are all just like any other function, little variables that disappear after the function's over. In order to persist them, in order to save them, I have to stick them into self. I have to put them in the table. So this is very typical in a constructor to actually have the local variable bow. You're going to use that to set the persisted variable self.bow. Okay, and self.hits is a persistent state variable that has a default value of empty. It's an empty array. Okay, so to use this constructor, let's go down to the bottom here. If I wanted to create a submarine, I pass in the 3 state variables that don't have a default, right? I need to give it the bow, whether it's horizontal or vertical, oh no, I'm gonna get better at this, but it's gonna take a minute. You see this? Oh my god. One moment. And then when I want to guess whether the ship has been hit, I don't have to pass in all those state variables. I can just give it the guess, which is really what I want, right? I want this ship to tell me whether it's been hit. You see? And the ship knows where it's at in space, and so the ship can tell me the answer to that question. And as part of that process of it searching through and trying to tell me whether it was hit, oh, by the way, what a perfect spot to update its state variable hits. You see? Like, Lenny, don't go in there and just set self.hits equal to some set of values. Only the ship can manage that quantity. And it's going to do that automatically by whenever you call the guess method, whenever you call the guess function. Okay? So then you could imagine writing another function for this class called isSunk. And that would return true or false. And how would you implement that function, isSunk, if it's inside the ship class and you have access to self? Remember, hits is a list of all the hits.
You could count the number of hits and see if that corresponds to its, length or
Yes.
width. Or,
Yes, length.
and then,
It's length, right?
Yeah.
Remember, there's no idea of width because we have a long ship and it's either vertical or horizontal. So length, if the length of self.hits is equal to self.length, then the ship is sunk. You see? And nowhere is anybody poking the self.hits state variable. Right? You guess locations on the ship, and then you can say, hey, ship, you sunk yet? And the ship will be like, no, I'm still there. Right? And it's figuring all that out based on its state variables. And so this is object, we'll call it encapsulation, right? There are parts of this thing which no one else sees, but the object itself exposes some methods that allows you to interact with it. Right, so it encapsulates the behavior of a ship.
So, sir, this doesn't have anything really to do with the board yet. This is just a way that you keep track of information for all the pieces.
Mm-hmm. Mm-hmm.
Okay.
Yeah, and it's going to be objects all the way down. Your board is going to have a list of ships. Right, and when you make a guess, you'll actually tell the board, hey, here's my guess, and the board will go, oh, I have 5 ships. For each ship in my ships, is it a hit? Is it a hit? Is it a hit? Right? And we'll see that in the code, right? In fact, already there's a lot of syntax that we haven't talked about in that in the Battleship code right now, which uses classes. And then on Thursday, tomorrow, we'll look at that more closely. You don't need to know how classes work or anything else for the first lab. So just kind of put blinders on and focus on those parts of the code where it asks you to write it. But we will use objects for everything. Does that answer your question?
Yes, sir. Again.
Okay, great. So the hardest thing, well, I don't know, maybe there's many hard things, but one of the very difficult things about using objects is actually how do you structure your program? Like what should be an object, and once you have an object, what methods should it expose, and what state variables does it need to have, right? A ship could have dozens of variables associated with it, or maybe just three, and so there's a design problem, which I think is a very can be hard, right? And it comes with practice. And so I'm going to give you structured objects already. You're not going to come up with a whole object out of whole cloth. You're not going to say, oh, you know what I need in this thing right now is a player object, and the player should be able to make guesses, and the player should be able to, right? I will structure the program, and you're going to populate the methods of a class, right? You're gonna write the functions. I'll tell you what this function should do, right? And I'll say, hey, now that you have all these classes, go ahead and build some objects out of them and have them interact with each other. And I think by the end of this, you will start to see how these objects, can be used well. So that our next project, when we start making websites and all, you can actually create objects yourself, right? Define the classes and everything. So that's kind of the zoom out view for now. But at this point, you should be comfortable reading code that has classes in it, seeing that word self and understanding what that means. So that tomorrow, once we start talking about making ships, all that syntax kind of gels, all that makes sense. Questions? Anything at all? All right. So one of students brought up yesterday a question which I think is pretty good. If you haven't noticed this, then don't worry about it. But if it has come up while you look at the code here, I just want to point out some syntax that I've used in the code that I provided for you that you don't need to worry about. So like line 16 here, I'm using the pygame display.set mode function, and that's going to actually create the screen. That's going to draw on Windows. It's going to ask the Windows operating system to produce a window with a little X on the top and the minimize tab, right, of a certain size. The thing that comes out of that function, the return value, is actually a object, right? And the type, the class of that object is called a surface. That thing is defined in pygame, and that's why we say import pygame. And so screen is a surface. The colon here is called a type hint. Python doesn't require this. The code is totally valid without it. Okay. The reason to use a type hint is so that later on in the code, when you're using PyCharm's autocomplete feature, it knows the different methods and things associated with screen, so that later on down here I can say screen dot and let's see, let's set this up. Right, you need to see that pop up here. I can say screen dot and then get the you got to do the right syntax here. Screen dot, and notice that on this drop down, you have surface type, right? First, those are all of the things a surface can do. And then you have other things that any object can do. And so that's just to help with the code hinting and autocomplete features. So you'll see that oftentimes whenever I define a variable, I'll put a colon after it and give it the type of that variable. That's the same as in C. In C, you would put the type before the variable because it's required, right? You'd say int x. So if none of this made sense at the end, don't worry about it, but that colon is called a type hint. And I don't expect you to write them yourself. I just put them in there so that when you use PyCharm and say dot something or other, it has a nice drop down with all the capabilities of that object. Okay. All right, so I think that brings us up to number 45 here. Any last minute questions? All right.
Yeah,
So
question on the lab. Can I ask you after class?
yeah, sure. Stick around. All right. So before class, tomorrow before lab, post to the Google Classroom your quick little screen capture, little video of the code and the game board fully drawn. Okay? All right. We'll talk soon. Have a great day.
I just had
Thanks, guys.